environments, and most of the models are in agreement. It's pretty good blue. It's probably 60–70%. And if we go to the 2080s, the average of these models is pretty much like one of that wetter in the other one where we're getting hemlock. And hemlock is disappearing in the valley bottoms, which is also agreeing with those other models that we were looking at. But you can see there's quite a bit more uncertainty. Look at something like ponderosa pine, which people don't associate ponderosa pine here. I mean, you got to go to the Okanagan, or you've got to go to the East Kootenays if you want to see it. And as the model says, today there isn't any. But as I was indicating before, those kinds of environments do begin to appear even in the next 10 or 20 years. And the models pretty much agree. There's pretty dark blue coming in here, particularly around Revelstoke. We go to the 2050s and into the 2080s, you can see ponderosa pine actually has lots of environment that it could grow in here, which is, again, if you think about Revelstoke being Vesuvius. So we're going to switch off vegetation and talk about water. We can talk about fish habitat. Like most of the fish that are important around here are fish that require cold water. So if you start melting snow, or you don't get snow, or you start increasing air temperature, of course you're going to increase water temperature. And that creates problems. This is some mapping that was done in the United States, looking at the amount of bull trout habitat that's available today. With a 1.5 degree increase in temperature, it shrinks to, I would say, a third. And if you go to 5 degrees, there's not much habitat left. This is looking at salmon. Historically, you got some temperatures that were stressful to salmon in the lower part of the middle part of the Columbia, around where the Snake comes in, south of Spokane, around the Tri-Cities area. But basically, salmon are okay, except in a really bad year. This is what's projected in the 2040s. And what it's saying is that temperatures that are projected in those waters then would probably be killing salmon. And this past year was a good feel, like last summer was a very warm year. It was a record hottest year again, globally. 80% of the salmon that came into the Osuyus, this newly restocked Osuyus, around 80% of them died in the States. And the ones that went into the Snake, 100% of them died. So it's starting to happen already in an extreme year. But there's lots of other things that climate change can do for fish. Loss of cold water, we talked about. Loss of streamside vegetation due to increased insects, disease, and fire. Competition from invaders. We're very concerned about walleyes and northerns, which are already at the bottom of the Hugh Kinley Side Dam. We start warming up the Arrow Lakes, creates great habitat for them. They outcompete our trout and potentially salmon and kokanee. Reduce slow flows, we'll talk about that a bit in a minute, but there's lots of things here that are going to be a problem for fish as well. So you don't normally think about fish and climate, but in fact, it would make a big difference. So the other question is, how are these ecosystems going to change? Is it just going to gradually change? You know, hemlocks will kind of disappear, and the ponderosa pine will come in, and everything will be gradual. Well, probably not. Because if you think about the way an ecosystem is, you've got, 20, 30, maybe 50 species of plants living in a particular site. Each of them have their own characteristics. And if the climate changes, it's going to change in one direction. Some things will change, some things won't. Some species will be able to tolerate that change, they'll stick around. There are other ones that won't be able to tolerate that change, they'll disappear. But there may be stuff that couldn't grow there before that can grow there later. So, in fact, rather than ecosystem just moving up, when I say the cedar hemlock is not that different from down here, but they may not just move there because it's not going to be identical to what it is today. What's likely to happen is these ecosystems are going to disaggregate, and then you get all kinds of new stuff coming in, and we're going to end up with completely different ecosystems, which creates new predator-prey relationships, creates new opportunities for pests as well. So what kind of things will bring about these changes? Well, probably one of the biggest ones is going to be fire. We talked about earlier that it's getting warmer and drier in the summer, which is likely to be correlated with an increase in fire. So the work that we did down in the West Kutenais, we looked, this is one of the actual modeling exercises we did, and this northern area of the West Kutenais is actually almost the same kind of climate and vegetation that we're dealing with in the North Columbia. So we're just going to look at this north section. This is the amount of area burned in that area over the last century. There's a provincial database that we've used to collect this. And you'll see that fires are very episodic. Like you'll get 1 year that's really hot and dry, and you'll burn a whole bunch of area, and then you might go for 6 or 8 years and burn virtually nothing. So what we did was, and in the south you can see there was a lot more area burned. In fact, this is 30,000, this was only 14,000. But what we did was we took the climate data back for a century and the fire data back, and then developed some regression equations to say, well, what kind of fire can we predict given the climate that's going to be moving forward based on the history in terms of what the climate was when we got those big fire years previously. And when we did this, what we found there was the main factor was the hottest month maximum temperature, the maximum springtime temperature, and the June precipitation. And it was interesting because these were slightly different depending on whether they were in the north, mid, or south. So these are the main factors for this area here. And you can think, because this is a fairly heavy snow area, this maximum spring temperature basically determines how soon the snow melts off. Whereas that wouldn't have been as important in the south because it always melts off early because it's warmer down there to begin with, and we don't get as much snow. June precipitation. June tends to be a wet month, and it will keep the forest wet into the summer, into the fire season. So if June is dry, the snow is melted off soon, those things correlate, obviously, with greater risk of fire. So this is what it looked like. This is the area burn. This is a log scale, by the way, so every line increases by a factor of 10. So we go to 10, 100, 1,000, 10,000. So this is how much area burned in the previous decades on average. These are 30-year averages. So it works out to, since the 1960s, about 600 hectares a year. What the models are saying, these are those three models again, is that on average, it's going to increase from this 600 to 6,000. So by a factor of 10 within the next decade or two. And by the 2050s, we're looking at a really big increase if we use all three models. In parentheses, I put in just the two models to show you, like, it's going to be at least that much, and it could be this much. Now, we're probably going to run out of fuel before we get to those large numbers, but it's fairly clear that we're looking at a big increase in fire risk. And one of the reasons, one of the reasons that the model probably doesn't work too well when you get out here is you think back that the model was built on climate for the last century, and as I said, we're going to be out of that range within 3 or 4 decades. So therefore, the regression model probably works for 30, 40 years, but beyond that, it's beyond what the data that we use to predict the relationship. So that's part of the reason. But I don't think it's any reason to assume that it's not going to keep increasing. There's no question about that, because summer precipitation is going down and summer temperature is going up. The other big changes, of course, are insects, pathogens, and various things that kill trees. So we've got episodic changes in disturbance patterns due to fire, but we've also got disturbance due to various other things that kill trees. Probably wondering about this woman here.
Yes.
So this is the joy of Google searches. If you search spruce bark beetle, you'll get this woman's wedding. It's because a spruce bark beetle went down in cleavage in the middle of the wedding. But we've already experienced probably the largest natural disaster in British Columbia's history, probably Canada's history, with the mountain pine beetle, which was due to just a lowering of winter temperature, or an increase in winter temperatures, which allowed beetles to survive. This is the amount of forest that was killed in British Columbia. Like, basically, the sawmill industry is disappeared in the Chilcotin for 40 or 50 years because there's no more trees to log. this is, there's numerous beetles that don't exist in British Columbia today that are moving north out of the States as things warm up. There's also complex things that can happen. Certainly down in the West Kootenays, we've had a severe dieback of birch. Is that happening here as well? So that's climate change related. In the next month, watch your birch closely. They'll be the first thing to leaf out. And that makes them extremely susceptible to these warm springs like we're having, or warm winters like we're having right now. They leaf out, and then we get a cold frost, kills those buds or kills the new leaflets, and then they have to rebud again, so they're stressed, they're weakened. And the last 3 or 4 years, if you notice, the leaves have been turning brown. If you look closely, they're not drying up. There actually are little leaf pores that are going out, and there's 2 different ones. And then they usually die from the top down, and that's because of the bronze birch borer, which finishes them off. But it's initiated by them being stressed by the changing climate. Yellow cedar is another good example of a complex situation. Yellow cedar is dying out at an extremely rapid rate on the coast, and it's dying because it's freezing to death. Now that doesn't make any sense with climate change getting warmer. But in fact, yellow cedar roots in the LFH, in the organic layer on the top of the soil. And because it's been warmer on the coast, you're getting less snow early in the fall, and then you'll get freezing weather, and there won't be a snow to insulate the LFH, and the roots of the yellow cedar freeze and they die. And it's going all the way from Vancouver Island to Alaska. So we can also talk about snow. Usually hydrologists look at snow. What they're most interested in is how much snow water equivalent. In other words, how much water equivalent is in that snow at, on April 1st. And that's what they use to predict the levels in the reservoirs, how much, when they should start filling, not filling, whatever. So this is looking at that number for projected for the 2050s. Again, this is an average of a number of models. So what you're seeing is at the lower elevations, we're looking at more than a 50% reduction in the southern part of the region. And in Revelstoke, we're looking at a 30 to 40% reduction in the amount of snow water equivalent. In other words, rather than building up snow in the winter, this winter is, I think, a good debut for what we can expect in the future, is that there isn't going to be any snow on April 1st, or very little in most years at low elevations. I'm just going to throw these on here. These are looking at the same kind of thing for going into the States. This is looking at the whole Columbia Basin, because of course BC Hydro and the Army Corps of Engineers are very interested in this information, because they want to know what is likely to be happening in the Columbia Basin and how they should be thinking about managing their dams. You'll notice that in the States, a lot more of it turns red, that they're not going to have any snow storage at all. Whereas we end up actually with some increases in your area because of that projection. There's going to be increased precipitation in the winter, and at the upper elevations, I'll show you in a minute, there won't be as much reduction in snow because, of course, like here in the winter, you're only a degree or 2 below freezing on average, whereas at the upper elevations, you're 5 or 10. So it gets 2 degrees warmer up there, it's still snow, whereas down here, it gets 3 degrees warmer all once it isn't snow. Well, that's what's happening even up to fairly high elevations in the U.S. because it's not as cold down there. So they're looking at 35% less snow with only a 2.25 degree increase in temperature. Now, the reason I raise that is, living in Revelstoke, you obviously care about the Columbia River and how your dams are managed. We're in the midst of renegotiating the Columbia River Treaty. What do you think the Americans are going to be wanting? More. Substantially more, because they're going to be under the gun. It actually gets worse because if you think about it, if you don't have snow water equivalent, it means that water runs off in the winter instead of being stored as snow. And normally we produce our electricity in the winter because that's when we need heat. But with climate change in the US, they're not going to need nearly as much heat, but they're going to need is air conditioning. And so they're going to want water in the summer. There isn't going to be that water stored in the snow and slowly melting off as it usually does in June and July because it'll be gone. Last year, again, was a good example. Even here in British Columbia, BC Hydro ran all their dams on the ponderosa at full bore all winter, because it rained, it didn't snow. And there was so much water there, they didn't want to waste it. So they didn't actually draw down the mica hardly at all last year, early in the year, because they didn't need to. They were producing electricity in the ponderosa. So it's going to be changes in the way things are managed because of these changes. This is just looking at actual projections for this area that are under 1,500 meters. This is the change in the proportion of precipitation in each season that falls as snow. So the winter is the blue, and the first one is the average from 61 to 90. So 75% fell as snow in the winter in 61 to 90. In the coming decades, it gets reduced to 60 to 50, and by 6 or 7 decades out, we're looking at 30% falling as snow. So basically, you don't have to worry about shoveling snow much in Revelstoke. Just have to wait. As you go up in elevation, of course, it gets better. And once we get up over 2,000 meters, there's not very much reduction at all. So like I say, we're starting out with a really cold temperature. You drop it 3 or 4 degrees, it's still below freezing. So we don't have nearly reductions, but there even are reductions up there. And this is some data from people up in Rogers Pass, showing that there's more to it than just whether it's snow or not snow. There's also what kind of snow it is. And I'm sure there's lots of skiers in the room who relate to that. This is looking at when they do their snow surveys up there, whether they encounter a crust in the snowpack or not. Before 1994, they encountered crust fairly infrequently. Since 1994, they've encountered crust most years, actually, which has implications in terms of avalanche frequency as well, or avalanche type. But the data that went with this, they weren't able to establish a relationship as to a change in avalanche frequency. But the snow definitely was different. Obviously, the other thing that's going to be impacted are glaciers. I mean, this is the silhouette. It's having significant impacts. And one of the things that I was surprised to find recently was that if you think about it, what glaciers there were in the southern third of the Columbia Basin, basically they're on their last legs. If you've seen Kutenai Glacier, it's just a remnant of itself. If you think about as glaciers melt, when they first start melting back, the amount of outflow that comes out of them increases because you're melting more and more ice each year. But you eventually reach a point where the glacier gets small enough that the amount of water that comes out becomes less because there's just not enough ice to melt. And so you think about that, we're well past that stage in the southern third of the basin. The stream data shows that we passed that stage in the middle of the Columbia Basin in the 1970s. And in the 1990s, we passed it here, and these are right in the midst of, some are down, some are still up. But it's probably a matter of a decade or two before we're on the downward limb everywhere in the Columbia Basin. So that means that your low flows in streams that have glaciers feeding the main part of that, your low flows in the fall are probably going to go down. Just talking about hydrology in general, this is using the Duncan Dam as an example. The black line is the 61 to 90 average outflow. So this is the flow in cubic meters per second. So we've got low flows in the winter, and then the spring freshet, and then we peak, and then it drops, and late in the summer we get back into that low flow situation. So these colored lines are all these different climate models with different scenarios run, and you can see they generally agree, but not perfectly in terms of what is projected to occur. But the general summary of what happens is that, as I was talking about before, as winter flows increase, peaks occur earlier. So instead of having a peak in around the 1st of July, we'll start looking at peaks middle of June, maybe even early June. Peaks are probably going to be higher because snow will melt faster, because when it turns warm in the summer, it turns really warm. And they're earlier. And summer flows and low flows will be lower. So if you're depending on stream water for your drinking water, you may have less come September, October. But every river is a bit different. So it depends on the elevation range of the river, it depends on whether it's got a glacier or doesn't have a glacier, but that's kind of a general pattern. And then there's the climatic extremes and what kind of impacts they're going to have. This is from Caslow. This is 100 years precipitation records for June. So in the previous century, the highest precip in June was 120 millimeters. In 2012, we had 206 millimeters. And actually the first 6-8 days of July, we got another 40. So you could say it was 240, twice the previous record in the previous century. And that's what resulted in the Johnson's Landing slide. So I have a place in Johnson's Landing, actually, just near the slide, plus 4 of my neighbors. But up until 2012, I thought, Kutenai's is the place to be. We're out of the way. We're not going to see the worst of this. But I think what this points out is that extreme events are extreme events. They can occur anywhere, and they can affect everybody. And I think we need to be prepared for that kind of range of events. These also can get complicated. This is Kuskanook at the south end of Kutenai Lake. There was a fire here in 2003, same year as the fires in Kelowna. We had that really hot, dry year. In this case, it was a very hot fire. We got water-repellent soils formed due to the hotness of the fire. And then in 2004, we had a summer rainstorm, water-repellent soils, put it into the gully. We got a debris flow, took out a couple of houses. Nobody was injured, fortunately. Took out the highway. Just another example of the kind of things we do live in the mountains. This just gives an example. These are projections for the city of Caslow, actually, and their water demand and projections in terms of how well their low flows will supply their water supply. Basically, what they're saying is that after the 2050s, the frequency of years where they don't have enough water is likely to become a problem. The good news is the water is going to be warmer for swimming. The only problem is, like I have a place, I say, on the north end of Kutenai Lake. If you've ever swam in Kutenai Lake, you know it is not a place that's warm to swim in. And 2 years it's been warm to swim in. Like you can actually stay in for half an hour. 2003 and last summer. But unfortunately it was so smoky due to the fires, you didn't really want to be in. So I'm not really going to spend a lot of time on this, but I think the important thing to think about is that we need to do something. This is, most of what you're seeing here is we've pretty well locked ourselves into. If you've got children or grandchildren, it's going to get worse unless we do something. We need to change what we're doing. And the other thing we need to do is adapt to these changes as well. I work mainly around conservation planning and ecosystems and forestry, and when you look at these projections and the kinds of changes in environments we're talking about, it makes a big deal. And you can look at that, and a lot of what I talked about is the 2080s, but if you think about it, the tree you plant today won't be mature enough to harvest by 2080. So if it can't make it to 2080 because the environment's changing that rapidly, we've got some serious problems to think about. So we're looking at, the workshop we're doing tomorrow is actually talking about kinds of things we can be doing. One of the things that I am working on in addition to that is a conservation strategy, was to think about, we've got all these species that are going to have to deal with that. Grizzly bears, ungulates, caribou. They're somehow going to have to cope with this if we want them to stick around as well. I think we need to change the way we're doing things. A lot of it isn't rocket science. It's basically things that we've been talked about doing for the last 3 or 4 decades, but for economic reasons or political reasons, we haven't been doing them, and now we have even more reason to do them. We're also looking at the fact that things are going to have to change their ranges. They're either going to have to move upslope, or they're going to have to move further north if they're going to find environments that are suitable. So we need to begin to look at changing our land management, identifying key passes and things like that where things can move through time, and managing them differently. But ideally, the kind of things we might do are things that do both, mitigate and adapt. One of the things people are doing are these interface fire treatments to try and increase our resilience to fire. But instead of just putting it in piles and burning it, we could be burning it in our fireplaces or our wood stoves or in boilers in our schools to provide heat and stop using propane, which is making it worse. But we're not doing that. We're just piling it up and burning it. In the States, they actually have a program where schools are given a low-interest loan to convert to wood, and then they sign a contract to buy this interface wood to heat their schools. And they actually have saved substantial, it's based on a 15-year payback, and some of them have paid back in 10 years because it actually makes economic sense too. Protecting forests, old growth forests for sequestering carbon, of course, improves the resilience for wildlife and other species, but it also reduces carbon emissions. Anyway. And obviously there's lots of things we can do ourselves too. But at the moment, I think getting the provincial government to stop trying to promote more LNG would be a good start. So that's it. I'm happy to entertain any questions, comments.
I just wanted to add a tiny bit about what we've been doing here in Revelstoke. In 2006, 4 climate scientists came and did a similar kind of this kind of a session and a workshop the next day, but it was a workshop with a broad range of citizens. And they actually said we were going to get flood and debris flows much more significantly. As they drove through the mountains, their eyes were just like that. And they expect the avalanches will change and things like that. So in 2006, when we updated our community development action plan, we incorporated that information into that plan. And so it's been there, and we've been trying to what we call mainstream it. It's lovely to have Greg, who knows all this stuff, but he's not there every day when you have to make a decision that might be impacted by climate change. So in the adaptation world, we talk about mainstreaming climate change into every decision that we make that has to do with the environment. So I'll give you an example of when I didn't mainstream, and you'd think I would, because I've spent time since 2006 working with a couple of handfuls of communities here in the Columbia Basin, with a couple of First Nations communities on the prairies, a community very much like us in northern Sweden, on adaptation. So here's my story when I didn't adapt, just so you can see how it affects just about every decision. I have a young nephew who's an adrenaline junkie. And for his graduation, I gifted him a heli-ski pass when I could barter with the heli-ski companies. It took him 7 years to decide he was ready to come. So he calls me last year and he says, I'm ready, I'm gonna come. I'm like so excited he's coming. I don't put my climate change lens on and think, oh God, it's a hot one, honey. Maybe you don't wanna come, we're in El Nino. You might not have the best snows. Why don't you wait until we're in a La Nina, where we're sure we'll have great powder? I didn't do it, but that's how you need to think all the time about climate change and every decision that has to do with where you are involved in the environment. And so back to the community, out of the 2006 work and also the 2003 fires in Kelowna, community wildfire protection became a big priority. So the committee was created, they did a plan, we got started as a community working on community wildfire protection. In about 2010, 2011, we had a workshop here with another climate scientist, Dr. Mel Reisner, who's also from Nelson, that Greg works with city staff, and looked at climate change adaptation issues for city operations. And one of the big ones that came up was our water source. Creda Creek is our water source, but fortunately it's north facing, which means it doesn't get really hot, but it is our primary water source. So the city completed a source water protection plan, the first piece of looking at our whole water system from a climate change lens. We were a pilot project in the basin, and the engineer that we worked with had never worked with climate change in her decision processes. And it was a big step for her to start to think about water supply from with the climate change lens. Fortunately, the outcome of that project was that our climate supply isn't at risk through to the 2080s based on the work that she did, like Caslo is. I'm a little unnerved about that. It was a pilot, it was a first assessment, but it was good to get that sort of initial response. So here in Revelstoke, climate change has been being tried to be mainstreamed for a decade now. And I encourage all of you as citizens to incorporate it, mainstream it into every one of your decisions as frequently as you can.
Cindy, looking at the number of fires that we may expect in the future, even here where we like to think we're so wet, do you think the city's been doing a good enough job for fire smarting?
The city has fire smarted every piece of municipal property that it owns that needs to be treated. We also just last year completed a fuel break plan, because trying to do fire smarting in our fecund ecosystems, our productive ecosystems, we have to treat them. So fire smarting is reducing the fuels on the ground and the ladder up, the branches that ladder up, and spacing the trees out a bit, so that when you do get a fire, it runs along the ground, it doesn't get up in the crowns, and the firefighters have a chance of suppressing that fire. If you have a building, it also involves keeping your piles of firewood and your propane tanks and conifer trees away from your building, 10-meter fuel-free zone. So the city properties are all fuel smart. We now have a set of fuel breaks all the way around the community except at the park, which of course it's a bit of a difficult challenge to figure out how to do fire smarting in a national park. But where we have a problem in the community is that private citizens are not fire smarting their properties. And so, especially in urban interface areas next to the forested areas, there are many properties with houses that have not done the fire smarting. I mean, this year we're going to work harder on with citizens to work on fire smarting.
So is that lack of education, or that they don't want
I think part of it's messaging. I'm actually going to work for the fire chief again this summer on that topic, and I think part of it is that all we've been really focusing on is the cutting down of trees, which isn't, you know, trees are dear to our hearts in this community in many ways, and people don't respond to that well. But I think if we focus on this 30-meter fuel-free zone first, 10-meter fuel-free zone first, so that around your house you don't have flammable materials, and some landscaping options, and then work out further, we'll probably get, I think, more people to accept that approach. I'm not sure, we'll see what happens.
The climate models are suggesting, or most of them are suggesting, a big increase in the tree line, big elevation increase in the tree line. How much is that going to be constrained by the soil up there? I mean, up in the Alpine, there's not much soil for those trees to grow in to start with. And also the avalanche, most of those Alpine areas are avalanche start zones. Trees take a while to establish in this avalanche path.
No, you're absolutely right. Again, that's why I kept emphasizing, I'm not saying these are the ecosystems that are there, but what I'm saying is that these are the climate envelopes that are typical where those ecosystems occur today. And so soils are obviously constrained. To say that those mountaintops, which are now rock and ice, are going to be close to western hemlock forest, no, they're not going to be. They're still going to be rock and ice. Well, they're going to be rock, probably no ice. Yeah, no, soils are a really big deal. And you did notice that the wetter model, which is actually ends up being the Canadian model, indicated actually an increase in alpine area. And the reason being that it's predicting a substantial increase in snowpacks, which of course drives where the alpine is. So, although in most parts of the world, yes, it is, you know, talking about tree line going up, it isn't always the case. I think that's why I kind of like to call it climate disruption and not climate change or global warming, because it's different everywhere. But no, your point is well taken. You're absolutely right. Yeah. Rock outcrops are rock outcrops, no matter what the climate is. Anybody else?
So what would your recommendations be to the people working on mountain caribou recovery?
That's a great question. I actually gave a paper to CIF at the CMI conference about 10 years ago on caribou and climate change, before we had as much information as we have today. What I would say, the quick answer, just based on what I presented here today, is that I wouldn't rule out hope for caribou here at all, because 2 of the 3 projections said that we're looking at some sort of cedar hemlock, be it coastal western hemlock, interior cedar hemlock, but at the mid and upper elevations. Those are habitats that are potentially suitable to caribou. They're not, they're humid. I mean, if we're looking at lichen growth, they certainly have potential for producing lichen. Whether they're gonna be exactly right for Alectoria, that's another question, I don't know, but I wouldn't rule it out for sure. The third one, well, if we go to the hot, dry one, yeah, I would say all bets are off. But I just actually completed a study last week with a couple of other people for Nature Conservancy candidate property in Darkwoods.
Yeah.
And we were asked to do a climate change projection and a fire plan for Darkwoods. And they, of course, is the Southern Selkirks spend most of the time on this piece of Darkwoods property. And the fire projections are way worse down there than they are here. Even the more optimistic one, well, the optimistic one is pretty good. The wet one still shows cereal, it's not quite as wet and dense as it is here. But again, here I would say the chances are 2 out of 3. Down there it might be 1 out of 3. The Purcells are sort of interesting. I mean, the other possibility is for caribou to move into Purcells, because Purcells actually picks up moisture, and so does the Rockies. I mean, the Rockies were caribou habitat many years ago, and we managed to do them in there, but they actually get moisture. The Rockies is a very different projections than there are here. And so to say there isn't going to be caribou habitat in the Kootenays or the Kootenays and Columbias in the future is, might be, might not be. I think it really comes down to that fire situation. If, you know, if we get really, really extensive fires at upper elevations, then yeah, I'd say we're in trouble. But if it goes to that more wetter one, the fires may stop at mid elevation and may not be. So I wouldn't give up.
Yeah, another question, have you been working with the Landscape Conservation Cooperative in the States? That
Not directly, but I am aware of them and have had some interaction with them, yeah.
In terms of promoting wildlife corridors?
Yes.
Yeah.
Yeah, I have given a presentation on that conservation planning on one of their webinars, actually. It's available off their website.
Yeah.
Yeah, the project I'm involved in, we've had interaction with them, and one of the sponsors is Conservation Northwest out of Bellingham, who are involved in some of their projects, as well as Wide as well.
Great, well, thank you very much.